Hello everyone, hope you are having a great Christmas break. This is round 2 of this video, so I'm not going to be writing in what I started off writing in because it did not work the first time. Classic. Alright, but we are talking about 7.2 sampling proportions, okay? So the question, our EQ, is how do we calculate mu sub p hat and sigma sub p hat of a sample proportion, p hat, and determine if it's approximately normal, okay? So, we're going to have mu sub p hat means that it's the mean of the sampling distribution, okay? And sigma sub p hat is the standard deviation of the sampling distribution. And so, the whole purpose of this is when you talk about a statistic, we say things like, about 12% of the teenagers do this, or whatever the statistic is, right? So statistic, remember, is a number that describes a sample. And so we take a sample and we say about blah, 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 okay? But how close is about? How do we determine what the probability is of something being about whatever? Okay, because it's just a number that describes a sample, but we want to be able to go back and figure out, well, how does that relate to the population? What's the parameters that we're talking about here? Okay, so we take a sampling distribution. Remember, a sampling distribution is where you look at the statistics of many samples. Usually it's all, but it's impossible to pull all the different possible samples, and so it's approximately a sampling distribution, like we talked about back in chapter 6, or actually not 6, 7.1. And when we look at the distribution, we are still going to describe it using our shape, our center, and our spread. And remember that shape we're talking about, is it unimodal, is it bimodal, is it bell-shaped, is it skewed left, is it skewed right? These are our shape terms, right? Center, that's where you talk about the mean and the median. And for sampling distributions, to talk about the center, we're going to talk about the mean, the mu sub p hat. All right, and for the spread, we're going to talk about, this is where we talk about like IQR, range, maxes, and mins. Well, we don't really worry that much about maxes and mins because there is a sample you could pull that 0 people would have done it, right? And so we don't really worry about that so much, and we don't really worry about the range, but we can talk about the standard deviation, okay? And that's the sigma sub p hat. So at first, a sampling distribution will resemble a binomial distribution. Okay, so remember how we looked at like the elk population back in chapter 6. So that was a binomial that we chose, right? The larger the number of samples, the closer it will be to normal. And so we can use this idea of something being approximately normal. And so it's going to become an approximately normal distribution, okay? And we're going to use that p hat is equal to x, which is the count of successes in a sample, divided by n, the size of the sample, okay? And so if this is the case, then we can say that mu sub p hat is equal to 1 over n times np equals p, okay? So the mean, the mu sub p hat, is just going to be equal to p. So we can skip this step because the n's cancel out. So mu sub p hat is just going to equal the proportion of the population that we're looking at. Now sigma sub p hat is going to be equal to 1 over n times the square root of np times 1 minus p, which is just equal to the square root of p times 1 minus p over n. So the proportion minus naught divided by n, take the square root. And we know as the sample size increases, spread, the standard deviation, okay, will decrease. Okay, so what that's saying is that it varies less about the mean. So the larger sample size that we're taking, so say you have a sample of 1,000, if you know what 20 people think, well, that's not going to give you a good idea, right? Your standard deviation is going to be large. Because we're not sure all the different possible samples. You could have picked a lot of other random samples, right? Now, if you have like a sample size of like, say, 100 out of the 200, well, that's a much larger sample size, and so you're getting a better idea, and so your standard deviation will decrease, okay? And it makes sense because n is here on the bottom of the fraction, and so the larger this is, the smaller this will be, and you square root it, blah, blah. All right. Now, remember, if n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10, we talked about this rule, or this condition back in chapter 6, but when you take this sample size and multiply it times the proportion, and then you take the sample size and you multiply it by not the proportion, if those two things are greater than or equal to 10, we can say that it's approximately normal and just use our normal CDF, our normal PDF to summarize things. So, in summary, the mean of a sampling distribution of p hat, our statistic, is mu sub p hat equals p. And if n is less than or equal to 1 over 10 n, then the standard deviation is sigma sub p hat is equal to the square root of p times 1 minus p over n. So you can only use this equation up here to find the standard deviation if our conditions are met. Okay? And our two conditions are the condition of large counts and the 10% condition. So if you take more than 10% of a population and sample, then we use a finite population correction, an FPC. Okay? So I'm going to show you an example, and we'll talk through all the different steps here. But here's our example. It says a sample survey interviews a simple random sample of 267 college women. Suppose that 70% of college women have been on a diet within the past 12 months. So we have a simple random sample. We have 267 college women. Okay, this is our sample size here. Now our capital N, the total sample that we could have chose from, is all college women. Okay, so suppose that 70% of them have been on a diet within the last 12 months. What is the probability? Okay, that 75%, which this is going to be our p hat that we're interested in, have been on a diet in the last 12 months. So we want to find the probability that p hat is greater than or equal to 0.75. Okay, we have a simple random sample size of n equal to 67 with a population proportion p equals 0.70 of college women who have been on a diet. All right, so immediately, right off the bat, we know that mu sub p hat is just equal to p, which is equal to 0.70. So we have the mean, okay? Now we have to see if this is approximately normal. To do that, we need to check the 10% condition, all right? So 10 times 267 is equal to 2,670. And because there are more than 2,670 college women to choose from, we have met the 10% condition. The next thing we need to do is we need to check the rule of large counts, okay? So we take n times p is greater than or equal to 10, which is 267 times 0.7 is greater than or equal to 10, which is 186.9 is greater than or equal to 10. This is true, so it meets that condition. Now we got to look at n times p not, or 1 minus p. So 267 times 0.3, because 1 minus 0.7 is 0.3, is greater than or equal to 10, so that is equal to 80.1 is greater than or equal to 10. So both our 10% condition and our large count conditions have been met, so we'll assume that this is approximately normal. We would like to find the probability that p hat is greater than or equal to 0.75. So we find the normal CEF. We have our lower bound of 0.75. Our upper bound, pick a large number, 1,000 works. Mu is equal to our 0.7. Remember, that is our p. Now to find sigma, our standard deviation, then what we need to do is we're going to use this formula here. So we have our proportion times 1 minus the proportion divided by the sample size and take the square root of it. So we get 0.7 times 0.3 divided by 267, take the square root. We get 0.0280. Alright, so we plug this in on our calculator. Okay, menu, statistics, distributions, normal CDF, I think that's 2. Menu 652 or something like that. And we get 0.071. Alright, so what that's saying is there is a 3.7% chance that of a sample of 267 college women, that 75% or more have dieted in the last 12 months. And that's kind of what this all boils down to. So we figured out the mean, okay? Mean's automatic. We have that the mean is going to be equal to p. Then we have to confirm that it meets the two conditions, okay? So you have both of your conditions, the 10% condition and the large counts condition. All right, and then you can use a you can find the standard deviation and then use a normal CDF to find the probability of something occurring. All right, so hopefully that is helpful for you. Make sure you read the section for yourself, and we'll do some more practice with this when we get back from the break. But you're responsible for 7.2 and 7.3 to take these notes, and there will be a reading quiz as well. All right, so hopefully you are having a great break.